Your fate might already be sealed. And this is why. Uh, okay, you have to stay with me here because for me to explain you how I am thinking about this, it's going to take some time because it's not a pretty simple concept. So let me show you what I am thinking. So let's say let's draw Roy. Okay, this is Roy. Roy is okay. First of all, let me set some constraints. We are an external observer of this universe. We are not involved in this universe. We are just watching it from outside. Okay. So Roy, let's say, was born in 2000. Okay, and let's make a line of his timeline. And assuming an average human is like 80 years, I'm going to say he died at 2075. Okay, so Roy has had a time. Roy had 75 years of life in him. Okay, so what is this? Okay, I want you to imagine something. Okay, I want you to imagine you are going to zoom in this. Okay, zoom in this. Should zoom into this. Okay. This is a frame in his timeline. This point does not represent any kind of time. It is not a change in time. It is an instantaneous frame in his entire timeline. Just as if a line has infinite point, this is a singular point in his entire life. This contains no information of time whatsoever. Okay, so we have this. To explain this, let me create another thing here and let me show you how I imagine entropy works from some very great YouTube videos and some very great explanation from teachers. See, you have four boxes, okay, and you have, let's say, one, two, three, four. You have four gas particles. Let me just color them so it's easily distinguishable. You have four gas particles, okay, and every one of these is inside this container. Okay, so once you open every container here, so let me just use an arrow. So when you open every container here, this container is now open. Now what will happen? You will still have one, two, three, four, everything, but you still have those boxes. Boxes are just to represent something, and let's say after some amount of time, the yellow one is now here. The orange one is now here, the red one is now here, and the green one is now here. So what has happened? Okay, shit, there was no red one. Okay, so blue. Okay, so the blue one is right here. Okay, so what has happened? You see, this is one way of representing all these stuff, and this is another way of representing these are all probabilities. uh, Let me show you this. Let's say you have a container here, okay, and let's make it an actual gas thing here. Okay, so see, the volume the volume is constant. A better word for me to explain this is not finite. It's finite, and there is volume of gas particles which are, let's say, in our case is also constant, and it is also finite. So a finite thing in a finite place can only have finite number of positions. Okay, you cannot have infinite number of positions in this. Like if you were to exist at this point, you will have some kind of, you know, uh, mass around you, so you will exist somewhere in this. So just because you're not a point, you cannot exist indefinitely because you have volume in this. Okay, so let's say there are these many gas particles here, and we have these many gas particles here. So when this container is like closed, let's say the entropy of the system is around 0. But when you open this container, suddenly you will notice that is there a way to draw dotted lines in this? Okay, let me just draw it. When you open the container, okay, so now you'll see that this is here, this is here, this is here, this is here. The red ones are here, 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 and here. So what has happened? You see, entropy of the system has increased. So let me just say this is entropy, different entropy has increased significantly because that was this was arranged and this is disorganized, so the randomness of particles has increased. But my point here is there such because it is finite, there is a point where entropy will be max. Okay, there is a point where where all these particles will substitute to an maximum disorder because there are finite spaces. A finite spaces means that it has a tendency to reach a state. So so in Roy's life, we have captured something like this. Let's say we have captured, let's say this is point A in our, we have captured the entropy state of point A in Roy. We have captured again the entropy state of A of Roy in his timeline. And from this, we can understand that the entire universe at that instance had some amount of arrangement of particles, okay, and we have basically captured every information of those particles, okay. So now you will know your brain is also made up of particles. Basically it's not very different entirely. So it is also made up of consciousness. No, it is made up of particles in our thing here. So every memory you witness, every input you witness from your hands, from your ears, from your eyes are all also just movement of particles in different ways. So they are also captured in this entropy state. All the memories of Roy is also captured in this entropy state. So Roy entire Roy existence at that instance is captured. And let's say you move a very 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 short amount of thing here, like a very small and very small but noticeable. Okay, so at this stage, let's say this is like a plus delta, delta representing very small thing. So this is state of entropy. Oh, shit. This is state of entropy A plus delta. Let's say you have also captured this, and let's say a single particle, a single particle moves in some other arrangement, a single particle, and you have captured the entropy state of this point here. Okay, and when you integrate all of these in Roy's timeline, you get the entire life experience of Roy in this universe and everything that has happened in the universe in Roy's existence. Hmm. Okay, keep this in mind. Now let's move on to another slide. And now let's try to figure out what just happened. You saw that we somehow defined Roy's timeline, time, in matters of entropy, which is actually true. If you go like deep into physics, time actually is not a very real thing. Time is what you call the interpretation of movement of entropy from low to high, because entropy from our observation, keep in mind we are not in the observable, we are not in the universe that Roy was living in, we are outside of it. So we are just external observers here, and we and Roy is imagining everything. Roy is experiencing everything as a movement of uh, particles from low entropy to high entropy. A very good example of this is you have, this is the top of a coffee cup. Let me make it brown. Okay, so not a very good color. So see, you this is milk. Okay, if I want to represent milk, just okay. This is milk. Okay, and what you did now, you dropped in coffee. Okay, so due to diffusion, I don't think diffusion is the no diffusion is the no. Okay, anything, you get the point. Diffusion in gases and in fluids. Okay, so due to diffusion or something, the particles gets mixed because due to, yet again, the random motion of particles. So see, entropy is just a mathematics. Entropy is just probability of every object existing in some type of way. So what you did now was very suspicious. Okay. You are trying to make Roy imagine that when you drop this, there is a mathematical possibility that this thing can be something like this. The whole coffee can just unswiggle its ways back to the origin of where you dropped it. And this is completely valid because it's just a movement of gases. There will be a state where all of these random movements will result in this. Well, not the no, barrier itself, we remove the barrier, we are not talking about that. But there is a mathematical possibility that this will result in this at some stage. So this is all very possible. But why don't we see it in our day-to-day lives? Because this occurrence is so approximately equals to zero, like so approximately equals to zero that we consider it zero. Because you see, a milk has so much amount of molecules, it has a lot of particles, it has a lot of particles, but well, for this thing to occur again, it has to have one in over that many particles. So let's say, let's just say, for a very specific kind of point of view, let's just say that you have 1 mole of gas. Okay, so this is 6.022 into 10 to the power 23 particles. Okay, and you have one particle singular, and you want this particle to be at A, and let's say A is just a position, and there are this many number of positions. Okay, so what is the possibility that this particle will exist in A? It is 1 over 6.022 into 10 to the power 23 my plus 1. You see, this value is so small that it's insignificant. You are dividing by 10 to the power of 23. This value is immensely small. So the possibility of having this occurrence is almost impossible, but still possible. Okay, this is still possible. That is what we are considering today. So Roy has this entropy state and we entropy shift. We have captured the entropy state of the environment, universe. Okay, now let's move on to something rather interesting. Okay, let's define our own system. Okay, so at the Big Bang time, like the starting of the universe, we say that starting point has entropy equals to zero. It's not true. I don't know actually. It's not true. I'm just defining my own terms of entropy. And let's say since space is expanding and the calculation says it will reach ending point at some point. Let's say it has an ending point. If it doesn't have ending point, this won't make sense. But let's for our thing, let's say it has an ending point. So again, if it has an ending point, which means its volume is finite and the volume of all the particles in it is also finite. So what did we learn from this? That there can always be S max. So my S max will be 100. Okay, I'm not going that big. So this is our definition of entropy here. We are no, let's forget about Roy. We are an external. We are an external observer here. So, so what are we going to do? Okay, we are going to see how the universe is behaving. We are at the starting point here, and this is the starting point. This is not a timeline. This is the state of entropy. Let's say at some instance, the entropy of the universe is, you know what? This can be explained much cleaner in terms of graph. Okay, so uh, how do I define that? Okay, you know what? I'm going to define time here. So this is not the time of Roy. This is our time. We are measuring it from ourselves because it will be simpler to think about it in this way. So it's our time. We are the external observer. We see everything, and we have information about everything that we will see. And this is our time. We have made our own time here. This is again. This is not Roy's time. This is just for explanation in terms of graph. And this is the of course the entropy time. This is 0 and this is 100. So let's say in our time somewhere like alpha in our time, the entropy of the universe is around here, so this will be like 30. Okay, and in the next instant, like alpha plus delta, delta meaning small, so at this instant the entropy of the universe suddenly shifts to 99. And okay, this seems so drastic, but genuinely it is truly possible because you can have a random arrangement. Okay, so this is kind of possible. Okay, not exactly possible because it's a very high change in entropy, but you will know what I mean if I just show you extreme point of views. And in the very and some noticeably time later, like beta, the entropy does to 25. Okay, let's say Roy. Okay, again, this is our own method. So let's say that Roy's timeline that we define here is from S equals to 80 to S equals to 83. Let's say this is Roy's timeline. So the universe is moving like this. It's moving in a random state. Should not have done that because, yep, it's moving very randomly, each representing this thing in our time. So Roy's timeline is about this, but as you can see, every point in Roy's timeline that could exist has already been captured because for a finite thing, Every position that particle can take is already defined. You cannot have an independently new position for the particle if you does not do not increase volume, because uh, the where did I show that? Okay, so for a finite space, the amount of particles that it can possess is constant. Same for Roy. The amount of stuff that he can do in this timeline is already defined. Yes, he can do things differently in his this area, but that's different. He will do differently, but for us, the observable, the external observer, we do not see any change because we just see it as an instantaneous frames. We already have the information of frames. It's like a movie. If you have every information of the frame, you will know how the movie will progress. It's no matter of time. You have every information of the entropy state of the entire universe, and it's like it's fluctuating so much. And the point is, Roy will never know about this. Why is that? Because Roy's entire existence, Roy's entire sense of existence is already predefined. Think about it a bit. Everything that Roy can do is already defined. And you see, the universe can move in any way it wants, but you won't notice it. The universe might as well be going down. It might as well have reached an entropy. Where's the? Okay. It might as well has already reached an entropy max, and it is now moving in the backward direction. But you will never understand this because for you, every frame is predefined. Every kind of sensory input you will get in that instantaneous frame is already defined. You cannot get any extra frame. Even if you move backward, think about it just a bit. Even if you move backwards, Roy won't feel a difference because if a ball is moving in this way and it has reached here and it has unconsciousness, it can observe itself. If you move it here, this point here will this point here will just be a phase where the ball is thinking that I have moved this much. And if you go this way, this point here will the ball will just think I have moved this much. The ball cannot observe how the universe is moving. Every process it can take is already predefined. So Roy is thinking that okay, I let's say I have lived a long life. He is thinking here I have to retire. I have to retire from my job, and this is the moment that he's saying, okay, I got my first salary. It's already defined. For Roy, this state is just how many distance he has moved here, and this state is how many distance he has moved here. He doesn't understand the meaning that the universe is moving backwards, but because for him, every state is predefined. It's that crazy that you cannot measure how the universe is moving. It might as well be destroyed in an instant and regained in an instant because every entropy state is defined. Let's say this exact moment is happening 10 billion years later from our time. This exact moment, let's say this is the moment I'm talking about, and this is the next moment, like just a little bit up. This movement has, let's say, a billion, 10 billion years apart. But for you, it's just 1 second into the future. Because for you, that doesn't mean anything because you don't observe this time. The universe destroys, recreates itself, and then destroys and recreates itself. You have no consciousness over how the universe is moving, but over your own sensory inputs that are already predefined. So that's why your fate can already be sealed. And uh, just before moving on, this is independent theory of mine, influenced by a lot of information that I input myself with. Okay, so this can be wrong. This can be 100% wrong. This can be way too vague. This can be some of you. Let's say, even if I'm right, let's say I do not even have the capability to explain what I'm trying to talk about. So let me see what are your thoughts in the comments about this, because I can be 100% wrong. It's just like a very intuitive hunch, if I can say that. It's not a very deep research topic by me. It's just something that I think could be true, and we have nothing to reason it out with. And something interesting happens in this actually. This is not something. This is something you will hear from everyone. No, this is different now. Let's say you have these things. Let's say there are two doors in front of you, and this is Roy. Let's say Roy moves into this universe. Roy moves into this door. So this is our example. So let me just do it like this so we understand it. And Roy moves into this door. So this is it. So according to probabilistic stuff, both of these are completely valid. And let's say if Roy chooses right, the possibility of Roy choosing this does not cease to exist. So you get two whole new universes. And basically, this is how the multiversal theory works. I don't know why I pointed this out here, but I think it is quite something. So I don't know. I just wanted to point this out. Okay, the ending was a bit random. Just me excited about something I want to just say. And I guess this is it for the video. Hope you guys enjoyed it. Please comment something that you think that I was wrong in, something you want to add, something you wanted to say that you think that could have been done better. So with that said, thank you all for watching, and uh, I will see you with something new weird that I could come up with. Till then, bye.